Dear students, today we are starting a new chapter, Chemical Kinetics. Kinetics deals with moving bodies. In chemistry, during a reaction, the reactants are moving to the product. The concentration of the reactants will decrease, concentration of the product will increase. And this happens with the different speed. And it is this speed of movement that is studied under chemical kinetics. During your first year of study, we studied thermodynamics. In thermodynamics, we deal with the spontaneous nature of a chemical reaction. Whether a reaction takes place on its own or whether it is having the tendency to take place. That much is learned. There is no mention regarding the speed of the reaction. For example, hydrogen combines with oxygen to form water. According to thermodynamics, delta G for this process is negative and hence the process is spontaneous. But if you mix hydrogen gas and oxygen gas in a vessel and keep it for days together, not even a single drop of water will be formed. Why? Is thermodynamics prediction wrong? No. Thermodynamics says hydrogen has the tendency to combine with oxygen, forming water. There is no mention regarding what are the conditions under which this reaction will take place and what is the speed of the process. And it is these aspects that are discussed in chemical kinetics. Chemical kinetics deals with the rate and mechanism of chemical reactions. Here we are studying different terms, and the first term that you are studying is the rate of reaction. Rate of reaction is written sometimes as ROR, or sometimes it is mentioned as initial rate or simply rate. And the symbol used is R. Speed is the change in variable with respect to time. Here the variable that changes, here the variable is concentration. So rate is the change in concentration with respect to time. So in the form of an equation, we can write rate is equal to change in concentration divided by change in time. Concentration is usually measured in moles per liter and the basic unit of time is second. So the unit of rate will be mole per liter per second. Mole per liter is also called molarity, represented by capital M. So it can also have the unit molar per second. In the case of gaseous reactants, concentration can also be expressed in terms of pressure units like atmosphere, bar, etc. So it can also have the unit atmosphere second inverse. In some books, liter is written as dm cubed. Actually in SI system, liter is not there, it is only dm cubed. So the unit can also be expressed as mole dm power minus 3 second power minus 3. The unit of time can be anything. The basic unit is second. Can be used in minutes, hours or years. In these plus 2 books, as far as you are concerned, we are not using dm cubed in your book, we are using only liter. Then, depending upon the rate of reaction, we divide the entire group of reactions into 3. The first one is fast reactions or instantaneous reactions. That means reactions which take place in a fraction of second. When you mix the reactant, immediately the reaction will be over. The explosion is a very fast reaction. One most common fast reaction is silver nitrate combined with sodium chloride forming AgCl and NaNO3. Immediately on mixing the solution, you will get the precipitate of silver chloride. This is a very fast reaction and we cannot measure the rate of reaction using ordinary methods. Second is the other extreme. Slow reactions, very slow reactions. This reaction will take days and sometimes months or sometimes years for completion. For example, rusting of iron. It will not be over in a day or two. Fermentation reactions. These reactions are also very slow, so it is very difficult to measure the rate of these type of reactions. And third type, it is the common reaction, which is having a moderate speed. And moderate speed reactions, the rate can be measured experimentally. One example is combination of nitrogen and hydrogen forming ammonia gas. So, ഇതിൽ fast reactions and very slow reactions. That is the first two categories. We are not at all studying. We are only studying the third category, the moderate speed reactions, the speed of which can be measured. Rate of reaction, we have two different types. One is called average rate. This is the rate during a given time interval, and other is the instantaneous rate. Average rate, I told you, this is the rate during an interval of time. Say for example, from 5th minute to 10th minute, or say 8th minute to 15th minute. So during this time gap, the rate is called the average rate. Instantaneous rate is rate at a given time, a fixed time, say 10th minute speed എത്രയാണ്, 15th minute. So at a given instant of time, the rate is called instantaneous rate. So what is rate? Rate is the change in velocity, change in concentration with time. So we write delta x by delta t, the mathematical expression for rate of reaction. Delta stands for change. The square bracket indicate molar concentration. So delta x is change in concentration of x. X is any substance divided by delta t, the change in time. So average rate is usually expressed as delta x by delta t. When the time interval comes closer and closer, it goes on decreasing, and finally when delta t approaches 0, delta x is replaced by dx in the instantaneous rate. And instantaneous rate therefore is expressed as dx by dt. So delta x by delta t represent the average rate, dx by dt represent the instantaneous rate. Instantaneous rate is the rate at a given moment or given time. Average rate is the average of the instantaneous rate during a time interval. That is the difference between the two. Now, how will you measure the rate of reaction? It is by drawing concentration time graph. And in the graph, on the x-axis, we are taking time, and on the y-axis, we are taking concentration. In the first graph, we are taking the concentration of the reactant. What happened to the concentration of reactants? It goes on decreasing, and so we will be having a graph. And how will you calculate the rate now? Say this is the time given. At this time, we have to calculate the instantaneous rate. Then draw a tangent through the meeting point. This tangent meet the axis at the points A and B. What will be the slope of this line? This y coordinate OA, divided by the x coordinate OB. So that gives you the instantaneous slope. Sorry, instantaneous rate. That will be equal to OA by OB. So this is the case of reactants. What about the product? In the case of reactants, the concentration decreases with time. But in the case of products, the time is on the x-axis, concentration of product is taken on the y-axis, and the graph will be going on. The concentration will be going on increasing. Here also, mark the time on the x-axis where you have to find out the instantaneous rate, and through the meeting point, draw the tangent and find the slope. The slope here also is equal to OA by OB, gives you the instantaneous rate. That is rate at a given time. Will this be constant? No. At different points, you will have different slope. So rate will not be a constant. That goes on changing with the time. Now, how will you find out the average rate? Average rate is the rate of reaction during a given time interval. Here again, for the graph, time, concentration graph, the graph remains the same. Now suppose here interval means 2 time will be there. So let the time is represented by C and D. At C, you find out the corresponding concentration A. And from D, you find the corresponding concentration B. So what is the change in concentration now? AB represent the change in concentration and CD represent the change in time. So the average rate will be AB by CD. That is change in concentration by change in time will give you the average rate. In the case of products, time concentration graph you see, again just like the same thing, you mark the 2 points C and D. From C, find the corresponding concentration. From D also find the corresponding concentration. So AB by CD will give you the average rate of reaction. So this we have 2 type of rates, average rate and the instantaneous rate. Average rate is represented as delta x by t, and instantaneous rate is represented as dx by dt.